You know, in the AI world, it's like we have this huge collection of specialists. We've got models that are amazing poets, others that are master coders, and some that are just incredible artists. But what if you could take all those unique skills and fuse them together into one single powerful supermodel? Well, today, we're going to dig into a really fascinating new approach that does exactly that. It literally treats AI models like a population of organisms that can be, well, bred for greatness.
All right, so here's our game plan. We'll start with the AI fusion problem, why this is so tricky. Then we'll get into the cool part, breeding better AI. We'll look at how this new method, M2N2, actually works, see how it did in some tests, explore why this really changes things, and wrap up with a look at the future, which is all about co-evolution.
So yeah, this really is the million-dollar question, isn't it? How do you merge an AI that's a poet with one that's a master programmer? I mean, in the open source community, we're swimming in these amazing, specialized models, but just mashing them together, it just doesn't work. Trying to combine these really distinct talents into one single, coherent mind, that's one of the biggest hurdles we're facing right now.
Okay, so let's dive into that, the AI fusion problem. And really, it's harder than it looks. The thing is, with literally thousands of these super specialized open source models out there for anyone to use, being able to merge them to consolidate all their different kinds of knowledge, that's incredibly valuable. It's really the key to building more powerful, more versatile tools without having to start from absolute scratch every single time.
And this whole process has a name, of course. It's called model merging. The goal is pretty simple, really. You take the best parts of a few different AIs and you combine them into a brand new single model. And here's the crucial part. You do all of this without the hugely expensive and super time-consuming process of retraining everything from the ground up.
But, and this is a big but, here's the problem with the old way of doing this. It was just so rigid. Developers basically had to go in and manually decide where to, cut and paste the different parts of the models together, and they usually did this along really fixed boundaries, like the model's layers. As you can imagine, this really limits your options. It severely restricts the search for finding the absolute best combination.
All right, so that brings us to the new idea, breeding better AI. It's a really cool nature-inspired solution. Instead of thinking of AI models as these static blocks of code, researchers started treating them more like, well, a population of organisms. Organisms that can evolve, compete, and even reproduce to create better and better offspring.
And you can really see the difference here. The old way was all about these fixed parts. It was basically a one-shot deal, right? You set the boundaries manually and hoped for the best. But this new M2N2 way, it's all about flexible evolution. The merging boundaries themselves dynamically evolve. This means it can explore a much broader range of combinations. And it's not a one-shot thing. It's a process that builds an evolving archive of high-performing models over time.
So let's put a name to this. It's called M2N2. Which stands for Model Merging of Natural Niches. At its core, it's an evolutionary algorithm. Its whole job is to breed better AI by automating and really perfecting this merging process. And it does this using competition, attraction, and these flexible merging boundaries to find powerful new combinations, all ideas borrowed straight from nature.
Okay, so how does this actually work? What are the 3 keys to its evolutionary success? Well, M2N2's magic really comes down to 3 key mechanisms, and all of them are designed to mimic how life itself finds the best solutions.
The real power here is how these 3 things work together. First up, you've got evolving boundaries. So instead of being stuck with fixed layers, the algorithm can actually find the perfect split points to create a much wider variety of combinations. Second, there's natural competition. Models have to compete for limited resources, which in this case are data points. This pushes them to get really good at specific things, which keeps the population diverse. And finally, you have smart pairing. This is basically like mate selection. It finds a model that's weak in one area and pairs it with another that's strong in that exact area. Pretty smart, right?
All right, so the theory sounds amazing, but the big question is, does it actually work in practice? Let's look at how they put it to the test, from math problems to creating bilingual art. The researchers put M2N2 through 2 really different, really challenging tests, one with large language models and another with image generation models.
So for the first experiment, they decided to fuse a math whiz with a web agent. They took one model, Wizard Math, which is, as you can guess, a genius at math problems, and they paired it with another, Agent Evolve, which is great at tasks like navigating a shopping website. The catch? On their own, each one is a total specialist and pretty terrible at the other's job.
And wow, the results really speak for themselves. Just look at these scores. You can see the parent models are completely lopsided. Wizard Math aces the math test but gets a 0 on web shopping. Agent Evo is the exact opposite. But look at the M2N2 merged model. It pulls off a really impressive average score, way higher than either parent. It managed to inherit the amazing web shopping skill while still holding on to a good chunk of the math skill. It became a genuine multitasker.
Okay, the second experiment was, I think, even more ambitious. They tried merging Japanese and English image models to see if they could create a kind of bilingual artist. The goal was to take a model trained specifically on Japanese image prompts and fuse it with a few others that were mostly trained in English. The big question was, could you actually create a truly bilingual AI artist this way?
And the result was just stunning. The final model they created didn't just understand the Japanese prompts, it actually generated images that were more photorealistic and more semantically accurate than any of its parent models. It took the best of all of them and became something better.
And we can see the numbers to back that up too. This chart shows M2N2 outperforming the baseline, the old state-of-the-art method. On the FID score, where lower is better, it comes out ahead. That's a measure of image quality. And on the NCS score, where higher is better, it wins again. That measures how accurate the image is to the prompt. So to put it simply, it didn't just create better-looking images, it created images that were more true to what the user actually asked for. So why does all this change things? Well, this is about more than just a clever new merging technique. It's about the surprising power of what are called emergent abilities. These experiments uncovered something really profound and honestly pretty unexpected about how new AI capabilities can be created.
Okay, so get this. This is the most surprising discovery of all. Even though the new image model was evolved exclusively with Japanese captions, the final version ended up understanding English prompts too, perfectly. It literally acquired a skill it was never ever directly trained on. This is a classic example of what we call an emergent ability.
And as the researchers themselves said, this underscores the promise of model merging as a robust transfer learning mechanism that resists catastrophic forgetting. Now, catastrophic forgetting is a huge problem in AI. It's when you teach a model something new, and in the process, it completely forgets what it knew before. This method seems to avoid that, which is a really big deal.
So if we tie all this together, what are the key benefits? Well, first, it fuses models without that catastrophic forgetting we just talked about. It can combine models that were trained on totally different goals. It has a smaller memory footprint because it avoids gradients, which basically means it's less computationally intense. And you don't even need the original training data. You could even use this to evolve models entirely from scratch.
So what's next? The future really looks like it's going to be about co-evolution. What we're seeing here is a shift, a whole new paradigm for AI development. We're moving away from painstakingly training one model at a time and moving towards co-evolving entire ecosystems of them.
And really, that's the big takeaway here. By treating AIs like a population in nature, by applying these principles of evolution, we can start to automatically evolve more powerful, more specialized, and more diverse tools. We are, in a very real sense, learning how to breed better AI.
So it really gets you thinking, right? What two AI skills would you fuse together to create something totally new? Maybe a master storyteller with a brilliant data analyst, or a composer with an architect? Let me know what you think. The possibilities are, quite literally, just beginning to evolve.